Welcome. All right, so now we're going to integrate this one using completing the square. And you may wonder, how do we know this is going to be a completing the square one? Well, we can't integrate the way it is. You might think, well, maybe it's a natural log. We got something in the denominator. Well, the problem is we don't have the derivative of x squared minus 5x plus 7 in the numerator. So if this were a natural log, u to u substitution with natural log, then there would be the derivative of x squared minus 5x plus 7 in the numerator, and there is not. So let's rewrite this. So we have the integral equals dx. Right, and then to use completing the square, we have x squared minus 5x plus, then b divided by 2 squared plus 7. Now you can't just go adding things wherever you feel like, right? But you can add 0, because 0 will not change the value. So we're just, to make that be 0, we're just going to subtract negative 5 divided by 2 squared to the 7. All right, so now we'll simplify. So that's the integral dx, x squared minus 5x plus 25 fourths plus 7 minus 25 fourths. All right, so we can factor. This is going to be x minus, and it would just be, it's minus because b is negative, and then it's just half of b squared, plus 7 is 28 fourths. 28 fourths minus 25 fourths is 3 fourths. All right, so now we have this rewritten. Let's reverse the ordering to make it match something more familiar. And now we see that we have a very familiar type of integral there. So if we have dx, integral of dx over a squared plus u squared, that's going to be 1 over a arctan u over a plus c. All right, so we have that format. Let's just rewrite it so that we have a something squared. So I equals the integral dx over, and this would be, so the square root of 3 halves squared, right, would be 3 fourths. Right? You square the square root of 3, you get 3, and you square the 2, you get 4, right? And then plus x minus 5 halves squared. All right, let's identify the u, the du, and the a. We'll do a u to u substitution here. So u is x minus 5 halves. The du is just going to be dx, because the derivative of x is just 1. Right? So the derivative of u with respect to x would be du dx. The derivative of x minus 5 halves, I could even show, we'll put the steps in there. The derivative of x minus 5 halves is just 1, right? And then we multiply both sides by dx, and that's how we just get dx. So du equals dx, right? Because the derivative of the u is the x minus 5 halves is just 1. And then the a is the square root of 3 over 2. All right, so now let's integrate that. All right, so I equals dx. We got a squared, which we can leave as square root of 3 over 2 squared. We just want to be able to identify it when we write the equation. Plus u squared. All right, and we know that's going to be forgot to write the integral. So that's going to be, I'm ready to simplify that. It's like, wait, there's nothing left to simplify. All right, so the integral is going to be 1 over a, which is 1 over the square root of 3 halves, arctan, and then u over u over square root of 3 halves. If you want, you can leave a's in there and not the numbers. I don't really have much of an issue with the numbers, so plus c. Right? But usually it's better to use a u for your expression if it's not just an x. Let's simplify that, so that will become, and then we'll substitute at the same time, and let's write that as an equation. So f of x equals, this will now be 2 square roots of 3 arctan. We're going to substitute in the x minus 5 halves. And if we're dividing by square root of 3 halves, that's the same as multiplying by 2 square roots of 3 plus c. Let's simplify that. F of x equals, I'm fine with the 2 square roots of 3, 2 over the square root of 3 unless you want to rationalize it. But I would definitely simplify this other part here. Let's distribute the 2, right? And then we've got arctan 2x minus 5 over the square root of 3. That looks much better. And then plus c. There we go. There's our integral, right? That wasn't too bad. Right? Once you rewrite the form using completing the square. Right, so let's do a few more completing the square. All right, here's another one. All right, so we have I equals dx. And we know it can't just be a u-to-u substitution with natural log because we don't have the derivative of x squared plus 10x plus 26. So this is not just a u-to-u substitution. Right? And if you've got something quadratic, try rewriting using completing the square, and it might fit into one of the inverse trig integrals. Right? So we have now x squared plus 10x plus 10 divided by 2 squared, and then plus 26, and then minus 10 divided by 2 squared. I gotta learn to make that fraction bar longer. All right, so now that'll simplify to x squared plus 10x. 10 divided by 2 squared is 25, plus 26 minus 25. So now we can factor this part. So we've got I equals the integral of dx divided by, this will now be x plus 5 squared, and then plus 1. Let's reverse it. So we got I equals the integral of dx over 1 plus x plus 5 squared. Let's identify the u and the a and the du. All right, so u is x plus 5. The derivative is just going to be 1 dx, right? And then the a is 1. So now we don't much need that in front, right? So if you should recognize that this is arctan, right? You've got 1 plus, you've got a something squared plus a something squared in the denominator. That is arctan, right? So, and we've got the derivative covered, the derivative of the x plus 5 already is covered. If it wasn't, right, then we would just have that fraction in front of the du, right? And that still wouldn't be a problem. It'd still be arctan. But we're not going to need the 1 over a, right? Because, well, 1 over 1 is 1. So the integral is going to be just arctan without the 1 over a. And then we will have u, right, which is, let's leave it as, let's do the u to u substitution, and then we'll integrate. Sorry, we didn't do that yet. I'm getting ahead of myself. All right, so dx 1 plus u squared. And that would be arctan just u, right? You don't need u, don't need 1 over a because that's 1 over 1. You don't need u over a because that's u over 1. Just arctan u plus c, and now substitute, and we got our equation. F of x equals arctan x plus 5 plus c, and that's it. All right, so if you've got something quadratic in a denominator, then completing the square. All right, let's try this one. Got a random line there. All right, so I equals dx. Got a radical this time, so it's not arctan. And then the square root, let's rearrange the order here. I'm fine with the 1 being first, but let's rearrange the x squared and the 2x. So we've got 1 minus x squared minus 2x. Now, if we're going to do completing the square, we have to have x squared, right? Not minus x squared. So let's factor out the negative. So we have I equals integral dx, and then square root of 1 minus, now that'll be x squared, and now if we have to factor it out of everybody, right? You're going to factor it out of both the x squared and the x, right? So that it's in parentheses by itself, and that a value has been factored out. And this would be true if we were just doing completing the square in algebra 2, right? If you're solving using completing this, or rewriting using completing the square. If you're solving using completing the square, you would divide everything by 1. If you're rewriting using completing the square, you'd factor out that a, right? If you were just solving, you would just divide by the -1. But we have to retain that negative because we're just changing its form, not its value in any way. So we are factoring out the negative. That makes that x squared plus 2x, right? And then we'll add the b divided by 2 to both sides. Right? Well, actually, we'll add b divided by 2 to the x terms, and we'll add minus b divided by 2. So here we have the square root of 1, and we'll put something in there, but let's put the minus over here, and then we have x squared plus 2x plus 2 divided by 2, because that's what b is, squared. Now that looks like 1, right? And then we'd have 1 minus 1. But we're not going to put 1 minus 1, because really, there's a negative there. We really added a -1, right? Because it's inside the parentheses with the negative. Right? So since we have a -1 on the right-hand side, we're going to put a +1 on the left-hand side. And if you get 0, you know you've messed up, right? Because you're not going to be able to integrate. And so I equals the integral of dx. Now we've got the square root of 2 minus, right? And now we can simplify that. That'll be x squared plus 2x plus 1. And then we can factor that. I'll just do that up here. I write too big. I use up half the paper here. Half the page. I'm going to write smaller in the next, not the next set, but the set after that, I've got several crammed onto one page. We're going to write small if it kills me. 2 minus, and now we'll factor this, and that would be x plus 1 squared. All right, so now we have to think of what format is that. Well, first of all, let me rewrite that just a little bit. All right, so I equals the integral dx, and I'm going to rewrite that as the square root of 2 squared minus x plus 1 squared. All right, so hopefully you recognize which one this is. So if we have the integral dx and the square root of a squared minus u squared, this is going to be arc sine, right? So arc sine, and then it would be u over a plus c. All right, so now let's just identify everything. So let's do a u to u substitution. So u is x plus 1. Always do that if it's not just x. U equals x plus 1. The derivative is just 1 dx. Right, so no problems there. Nothing to worry about. No coefficients to add in. So we have du over, hopefully I remember to put the du. I just thought about that. Did I put the du on the last one? Let's check. Square, because this is the last one I'm going to do. Square root of 2 squared minus u squared. And of course our a is the square root of 2. And if you want, you can put a right there if you'd like. But using the square root of 2 is fine as well. So now we know that this integral is going to be arc sine of u over square root of 2 plus c. And then let's substitute back arc sine, and u is x plus 1 over the square root of 2 plus c. And there we got it. All right, so not too bad. And I think that's the last one in this little set here. I can check. Yep, last little one. Let me see if oops, yep, I thought I did that. Ooh, that's bad. Don't do that. That should be a du. They need to match. Let's see if I do anywhere else. Yep, So make sure that your variable of integration that matches everything else. Okay, there we go. All right, so don't have dx's mixed with u's. Make sure you have du's. So there we see we had 2 arctans, and not to be left out, we had 1 arcsine as well. All right, so a handy technique when you've got something in a denominator that includes a quadratic, try completing the square, and you may match one of the inverse trig integrals. All right, so in the next video, we're going to look at one more technique. All right, bye for now.